I'm Jan Visser. I'm the principal editor of a book on seeking understanding. And the book is about building the scientific mind in a lifetime perspective. Matthew Colless, an astronomer, a very important astronomer, I would say, in Australia. I guess the most significant one in your country. You probably wouldn't want to say that yourself, but some that I know about you, that is sort of you don't have royalty anymore, but so you're not an astronomer royal, but...
No, that's right. We still have the Queen as head of state, but other than that, we're a Commonwealth.
Exactly. But we first met actually in, I think it was 2009, at a festival in Grafton.
That's right, my hometown.
It's your hometown, exactly.
My hometown.
And that festival was about philosophy, science, and theology.
Correct.
I had doubted if I should participate because I know very little about theology, but I know quite a bit about science and philosophy.
Well, that made you one up on me because I only know science. I don't know philosophy.
Yeah, well, that actually brings us to the issue of if you grew up there. What is it in your growing up in the environment that you were there that drew you to a career in science?
Well, the most obvious thing is that both my parents are scientists. They are agricultural scientists, and I grew up on an agricultural research station, basically a big farm, out in the country, out beyond Grafton, which is not a very big town. Mm-hmm. And I grew up under very dark skies, which meant that the beauty of the sky was always there for me to see.
Oh, wow.
And so with parents with a scientific turn of mind and the beauty of the sky before my eyes every night, and with a real internal hunger for understanding the big questions about the world, scientific, philosophical, theological, and other, I naturally gravitated towards science, and within science, towards the science that I felt asked the biggest questions, which in my mind were questions about the universe. Where does it all come from? What does it all mean? Where's it all going? And so, without ever framing it in those terms, I naturally became a cosmologist.
Mm. Yeah, and those questions that you're referring to, they're probably questions that have been asked over and over again by humanity since we emerged.
One of my favourite cartoons is actually just has two panels. The first panel shows a caveman staring out to the night sky and asking, what the heck does it all mean? And the second one is an astronomer with a very big telescope and fancy computers and everything, looking out to the night sky and asking, what the heck does it all mean? And I think that encapsulates a lot of humanity.
Absolutely. And do you expect it any time to change?
No, not in the least. I certainly hope not.
Science is about asking questions, isn't it?
And when you find answers, asking better questions.
Exactly, yeah. Well, we look in this lifetime perspective, obviously just back only at our own lifetime, back and forward. But then, as one of the authors of the book argues, we should not just define ourselves in terms of our lifetime, but look beyond it in the past and in the future. There are generations before us on whose culture we build.
Yes.
And there are others who come after us who inherit what we contribute to that culture.
Absolutely.
How did it work out in your case?
Well, I'm very much a child of what is broadly termed Western civilization, the Greek, Roman, Enlightenment tradition. I feel very at home within that tradition. It shaped me, it formed me, and I am broadly accepting of that tradition. But I do think that there are many things that we need to change, things that can be improved. And so one thing in particular that I am very keen to change in my own field and in my own country is the participation of women in science, which is, for most of the history of mankind, been suppressed and made difficult, and we've thereby lost half the talent and innovation and inspiration that we could have otherwise had. So I spend quite a deal of my time working to try and improve that in my own sphere of influence.
I saw a trace of that on your Facebook.
Mm-hmm. May have. Yes.
Yeah. And that is one group whose contributions to the development of our culture is being suppressed in your country and in many other countries. What about the Aboriginal population?
Yes, so again, this is a really important area for us in Australia. Unfortunately, Australia is very much a colonial country. We came in, we almost annihilated the local populations, we European settlers. My own ancestor who came to Australia came unwillingly. He was one of the convicts who were transported unwillingly to Australia. But thereafter he, like all the other settlers, did their best to dismantle and destroy the local cultures. And we're only just beginning to recognise the depth of that destruction and also the amount of knowledge that we lost. The Aboriginal understanding of the sky was profound and in many ways quite intriguingly different to European understanding. For example, because they were living under very dark skies, they saw the night sky as being bright compared to the dark earth. And so the features that they often picked out in the night sky were not the bright stars and constellations that Europeans looked at, but rather the dust and molecular clouds and other dark features in the background. So some of the most prominent features in Aboriginal astronomical lore are in fact dark features, not light features. So in fact, the dust clouds that block much of the centre of the Milky Way from our sight, they call the emu in the sky. And when you look at it, it actually is a beautiful representation of an emu with its legs and body and long neck trailing across the centre of the Milky Way.
Wow, that's fantastic.
Yeah. And of course, they were, like many early peoples, they were terrific navigators by the night sky. They had their own systems for doing it, and they had trails which allowed them to map their way across the Australian continent.
What about the influence of that's what we would call scientific knowledge on the mythology that they built?
It's hard to say. We've got so little record, both because, of course, they didn't have a written culture and because so much of it was destroyed so quickly by the Europeans before it could be studied, that we've got relatively little understanding of how much they knew and how much they didn't and the ways in which they thought about it. They very much tended to think about it in mythological terms, like almost all early cultures. So they had stories for everything in the sky, but the extent to which those stories reflected a more scientific understanding is hard for us to know now.
Mm-hmm. Well, let's turn to your chapter.
All right.
It's about beauty.
It is, yes.
And
scientific beauty, at least.
Yes, but you discovered beauty in various ways in your childhood, as you already explained. But here you are treating it, as you mentioned, in a very specific context, in that of science. And many people would not actually relate that concept to anything that has to do with science. So you'll have to do some convincing.
All right. So my personal experience and the experience of many scientists I've worked with, I think most, if not the great majority, is that their response to scientific facts and knowledge and arguments and theories and hypotheses and models is very much an aesthetic response. That this is a beautiful fact, this is a gorgeous theory, this is so elegant and pure and refined. All the words that we use to talk about art or to talk about music or other things that we more naturally think of as being beautiful, we use those same concepts to talk about science. And we do so in a highly analogous way. We're looking for the most beautiful theory to explain something, and it's beautiful because it's elegant, it's pure, it's simple, it has the right shape and form all those words that we use to describe beauty. So for many of us doing science, the aesthetic drive is incredibly strong and important to us. It shapes the way we think about things. But as I argue in the chapter, it's actually more than just a response to what we're doing. It's actually a heuristic by which we actually search through an incredibly complicated landscape of ideas, concepts, models, theories, facts, and try and pick out those that are most germane, those that are going to work in a scientific sense.
I remember when we were in Lembang at the Building Scientific Mind Colloquium there at the Boscha Observatory, we had defined as a theme science and technology in the service of beauty and harmony. And you reverse that order of words for that purpose that you just explained, right?
I did, yes, because I think it is two-way traffic. Science and technology certainly can serve beauty and harmony in society and in every other way. This is undoubtedly true. But I also feel that it flows the other way, that our ideas of beauty and harmony and our whole internal mechanisms for appreciating those things is in fact an incredibly important input and guide for how we do our science. Mm-hmm. And in my chapter, I try and explain how I think that works and give some examples for where I think that's been important.
Yeah, it's probably a very interesting example of coevolution of different dimensions in culture.
Yes, well, I think actually it's something that actually flows through all of human thought, that we have both our conscious mind, which can do logic, which can be rigorous, which can be, or at least try and be objective. But we also have all the underlying emotional, heuristic, subconscious thinking that has served us for most of our evolutionary history and which is still there and still trying to serve us in our new field of conscious endeavours. And of course, as many scientists will tell you, we have our best ideas in the shower. We go away, we think about things very consciously and rigorously and logically. We work through it at the very front of our mind. But in fact, it's when we allow our subconscious mind to take all that work and work on it in the background that we often come up with our most original and imaginative ideas. And I think that's actually a similar mechanism. What I'm talking about is a heuristic, partially conscious but partially subconscious way of responding to this incredibly complex set of things which our conscious mind is not capable enough, not large enough, not smart enough to deal with purely in intellectual terms, and it applies some heuristics to them. They're rough and ready, they're sometimes right, they're sometimes wrong, but they allow us to go very fast, very quickly, at the expense of making some errors. And so in that regard, it's very much a evolutionary response of capabilities we already have to a new situation. Science is a new thing for humanity, and we're taking all the tools we've used over our whole past history and trying to adapt those tools, a very evolutionary thing to do, to the new situation. And beauty is both the output of those heuristic rules. Beauty is our subconscious mind telling us, look here, this is what is a good place to look for our scientific theory. But it's also the reward mechanism. Beauty is something that we have a positive response to. It gives us pleasure. And so seeking beauty is a reward mechanism for us as well. It reinforces us looking in those areas.
So it's not just what we call a method. It's a heuristic, it's an approach, it's a way to discovery.
Absolutely.
Right?
Most of what the human mind does in dealing with the world is not logical thinking at all. I recognise your face, not because I've listed all the features and then go against a checklist and tick them all off, but because my mind just automatically folds them all together and in some black box neural network buried deep in my brain tells me that you're Jan. And I recognise you. In the same way, we should be able to take those same capabilities and recognise truth in science or in our model building or our hypothesizing and recognize promising lines of inquiry. They may not be right, and until we check them intellectually, they're not science, but it's an incredibly powerful tool for dealing with an overly complex situation that our very limited and still relatively primitive conscious mind can't cope with all on its own.
Yeah, we luckily have that primitive subconscious mind.
Yes.
It's in fact reflected in our brain structure also.
Absolutely, and far more of our activity in the brain is going on in the subconscious mind than in the conscious mind.
Yeah.
The conscious mind is a very new little pilot riding a very old and rough beast, which is where all the power is in our brains.
Yeah, and it's sometimes runs amok.
Absolutely. Absolutely, and that's why we've developed consciousness, because it allows us to have a jockey on this great big horse and sometimes steer it in better direction.
That raises a question about the scientific community, actually. It came up in my mind while I was reading your chapter. You say, we scientists, we are driven by that construct of beauty, we are after beauty, but does it really apply to the scientific community at large?
Oh, I think it applies to almost all scientists. I think they all can recognise that. It's not necessarily the main driver for many people. Many people are just trying to earn a living and take some pay home to their families. So it's not the only driver by any means. But when a scientist is doing science, earning more money doesn't tell you which is the right model or which facts to explore. It doesn't help you. It's motivating you. It makes you concentrate on that. But it doesn't actually help you to the problem.
Yeah.
Whereas the concept of beauty is actually useful in doing science, in the sciencing bit, right? It may not be why you're doing science. You may be doing it for some great social good. You may be doing it because otherwise you won't get paid tomorrow. But neither of those things help you do science.
And you may do it for very bad things as well.
You may do it for very bad reasons.
There are examples in history, unfortunately.
Science is a tool. Like every tool, it can be used for good or for ill.
Yeah.
No question.
Mm-hmm. Yes, and in my perception, it particularly applies to those scientists who are passionate about their research, and there are others who just do what their boss tells them to do, and that's right. That's what keeps them busy. Passion
is an emotion. Yeah. Aesthetics are an emotional response.
They might
two are going to be coupled.
They might still enjoy the beauty, and that's what I heard in the labs where I worked. Was more a word like it's funny rather than beautiful. And also it's you could say what's beautiful that this happens or whatever, but it isn't that profound sense of beauty that's.
I'm not going to claim that this is the only driver for anyone. Not for me. I enjoy the fun of doing science. I enjoy going to conferences in interesting locations and meeting interesting people. All of that's fine. But in focusing on when I'm actually doing science, when I'm doing the most profound part of science, what is the tool I call upon? Yeah. This is the tool I call upon. Other people can call on other things. And of course, we all have to call upon our scientific training and logic and all of those aspects. That's a given. But I also call on this tool, and many other scientists do as well.
And there's pleasure involved in it, of course, and
absolutely.
We should enjoy that. And I recall Richard Feynman, the pleasure of finding things out. That is indeed a great pleasure, and finding things out is exactly that heuristic that you're referring to.
Absolutely. One of my other favourite cartoons is this man glumly sitting at a party and telling the woman next to him, my big mistake was going into cosmology for the money. That's not why we're in it. If we were in it for the money, we'd be doing something else altogether. We're in it because this is what really makes us feel good about ourselves. This is what drives us. As you say, for many of us, it's a passion. And of course, in any field, people who are passionate about what they're doing do it better than people who are ho-hum about it.
Yeah.
Level of motivation matters.
Absolutely. It should be given more importance in the school system, I presume.
Absolutely. Imagination and passion.
Yeah.
confidence, all of these things are such important traits for any field, science or anything else, and all of them need to be built up in our children. I hope that's one of the things I've given my children.
Mm-hmm. I remember in Grafton, actually, the people refer to your having been a child and a school-going boy there, and I think one of your teachers was at that festival.
That's right, he was,
correct?
yes.
And having good teachers.
Absolutely.
It's
incredibly important to have people who inspire you, or who open up the world for you, or who just tell you that you can do it, that you are smart. All of those things are incredibly important,
Mm-hmm.
More for some people than for others. I think about my son and my daughter, who are polar opposites in many ways. My son's always sure he's brilliant and wonderful. My daughter's always sure she's failing and miserable. And actually, they're both perfectly equally capable of everything. But because of their different personalities, my daughter needs to be told that she's wonderful and clever and smart. And then she is. Whereas my son often needs to be told, well, hang on, maybe not so much. But, so different people. We need to work with individuals and develop different views. And of course, different perspectives are incredibly important in science, right? For all I may be concentrating on the beauty of something, I need someone else giving a different perspective on the science, because there's no one right way to do it.
There's probably something to say about curriculum as well in schools, and the way that things function according to a scripted curriculum makes it difficult for passion to be present in the interaction between teachers and students.
Yes, it does.
So the emphasis should be entirely different.
I have had people come to me, undergraduates with brilliant undergraduate careers, who had never thought for themselves at any time. And when I've said to them, look, here's an interesting problem, go away and come back to me and tell me what you think about it. They've had literally no idea what to do with it. They've got brilliant minds, but they've run along rails their whole lives. Mm-hmm. And they're not able to go off-piste and wander off into the unexplored backwoods. I've had other people who have not been particularly brilliant in their undergraduate careers, but who, once you set them free, they're like unchained, and suddenly they've got so much more that they can bring to the whole enterprise, and they've got imagination, they've got feeling, they've got judgment, they've got all those extra things that didn't matter so much in their undergraduate careers when they were following a set curriculum. But once they're having to do research, are incredibly powerful. I always say that once you get to a certain raw level of capability in the intellectual part of research, beyond that, much of it is about character, about passion, about imagination, and all those things that are so hard to test.
There is another chapter in the book written by a person who also attended the colloquium in Lembang, who said, well, he didn't set up, but he was involved in a school that emerged in close to where he has a professorship at the university, Sacramento, California.
I remember the talk.
You remember
that?
that?
I do, yes.
And Maria and I went to visit that school at the time, just months after we met in Lembang, and saw what happened. It's kids from a what I call minority community, Latino community, disadvantaged in many respects in terms of linguistic abilities. But they were totally curriculum free. They just let the kids explore whatever their interest was, and it was beautiful.
Mm-hmm.
It worked perfectly well, and even when it came to judging it in terms of the standards that society demands, their students didn't perform worse than ordinary students who had gone through curriculum, but they enjoyed it so much.
Yes.
And they definitely saw the beauty. unfortunately, that school was called to order by the school board
Yes.
about a year after we were there, and it became just a regular school. I went back there and talked to the students who were still there, who had lived the past experience, and in the conversation that we had, one thing that struck me was that one of them said, "It's so sad for those who haven't had the privilege that we had."
I certainly think that just as there are many ways to do science and many types of personalities, there need to be many ways to educate kids, that there is no one right way, that some kids need a formal, fairly strict curriculum and would thrive in that sense. Other kids would thrive given no curriculum, and everything in between.
Exactly.
And we need people being educated in different ways so that we come up with more different perspectives. If everyone's educated the same, everyone has the same outlook, and we've diminished the variation in our population. So to come back to my evolutionary model, a population that doesn't have variation is not robust when adaptation is required. You need a highly variant population if you're going to survive big changes. And if there's one thing we know that our world is going to go through in the next few hundred years, it's big changes. We need highly varied populations of people trained different ways to deal with the incredibly difficult problems we have before our civilization.
And you need a varied school system for that
Absolutely.
matter. Yeah, absolutely. You're mentioning, you're making reference to the world to come. And in fact, the world we have, the term Anthropocene probably makes sense in that connection. We have a tremendous impact on our own living environment, on the question, will we as a species continue to exist or not?
Yes.
How do all those things that we talked about play out in that context?
So it's interesting. In my chapter, I was positing that we can actually develop our intuition for beauty in science by actually changing the landscape of how we reward that, training it, in other words. Now, this is the same as humans have been doing over all of recorded history in breeding plants and animals in order to get particular outcomes. Now, basically, to do that, what you do is, instead of accepting the fitness landscape that your evolution is working within, you actually modify the landscape. You change the things which natural selection is selecting for. Now, you can do that consciously and in a modest and limited way, which is how we do plant breeding, for example, to get green roses or blue roses or whatever it is people need to grow. We can do that for scientists by, as you say, training them different ways and actually looking at training this sense of beauty into them, and not just giving them the intellectual tools, but giving them the tools for the subconscious, the aesthetic tools as well. But all of that presupposes that you can not just modify the fitness landscape, the selection parameters, but in our future, we're changing that landscape ourselves, but in an uncontrolled way. We are warming our planet so severely that we are completely changing the habitat in which we all live. Now, we're not doing that in a conscious way, and if we don't respond to that and modify it and change it again, we could potentially cause our entire species to go extinct, even all life on Earth in the most extreme cases. Now, if we are more thoughtful about that, if we can get our whole species under sufficient control to modify that, we can actually change that in ways that actually are beneficially evolving our species, selecting ourselves to be better at collaborating with other people, more cooperative, more able to live as a social animal, more intellectually capable, more willing to allow our intellect to override our rawer animal emotions. Now, all of that is a big ask, but that changing landscape is an opportunity for us. we will evolve in response to that change, whether we like it or not. Evolution is not something you can opt out of. The question is, can we both change to adapt to it, but also use the changed circumstances as a tool for adapting ourselves as a species in ways that will be beneficial to our continued existence on this planet.
We need to transform ourselves.
We need to transform ourselves. And evolution is the primary way that we have transformed ourselves. Now, we can transform ourselves by old-fashioned natural evolution of our genes and our bodies and everything else. But we need to evolve our minds. We need to evolve our societies. We need to evolve our civilization. And all of those structures respond to the same evolutionary criteria.
Mm-hmm.
There's a variation in the population which responds to natural selection, which is a feedback loop which changes the population. All of those things evolve. Evolution is the most significant paradigm for our species, both in terms of our biology and in terms of our civilization and everything in between.
Mm-hmm.
And we need to start thinking more about how we are evolving ourselves now that we actually have the levers that control the natural selection that's operating on all those levels of our species, from society down to the purely biological.
Mm-hmm. You said something about our intellect controlling our raw emotions, I think. What about the reverse of that?
Well, we certainly need to shape our emotions in ways. Our intellect is just a tool.
Yeah, but isn't there a need also to control our intellect? Because isn't it the disjunction between our emotional being and our intellectual being that causes the problem?
Well, it certainly can be. As I say, our intellect is evolved as a tool which made us more capable species. But like every tool can be used for good or ill. And our intellect does not make us do right or wrong. It's not the part of us which judges ethical things. It can allow us to evaluate them, but it's not making the actual decision.
But we have developed our intellect to a level that we can do so much more than what we are emotionally able to sense. You were referring to the fact that we have let the world develop the way it is. Why has that happened? If we have this supreme intellect, somehow we don't control that sufficiently.
Perhaps, although whether it's the intellect running off the rails or whether it is the lack of ethical understanding at an individual and societal level is something we could certainly talk about. And I would argue that ethics is not purely an intellectual exercise, it's also an emotional and subconscious thing. And until we integrate those better and come up with better training for that side of our being, then we're going to create scientists who have no ethical basis on which to work.
Exactly.
And that's incredibly dangerous.
Yeah. Matthew, perhaps to round it off, your current research.
Right.
What you're doing.
So I'm a cosmologist. I'm interested in understanding the universe in a scientific, physical way. And one of the ways of doing that is to actually make maps of the universe. I've spent most of my life surveying the universe, making maps of where galaxies are. And the reason that that's not just mere cosmography, merely map making, is because the patterns in the galaxies, the patterns in matter in the universe, are in fact an incredibly rich response to the physics of the early universe. In fact, by mapping where galaxies are today, we can in fact measure the age of the universe, the size of the universe, the constituents of the universe, the different types of matter and radiation and other energy sources in the universe. We can map how they've evolved over the time since the Big Bang. We can in fact infer an incredible amount about our universe simply by mapping where everything is. So that's what I've spent most of my life doing. I've been very fortunate that in the 30 years that I've been doing science, since I got my PhD, we've had an explosion of knowledge in this field due to our advances in technology that have allowed us not just to map small areas of our local neighborhood in our galaxy, but to map the whole galaxy and in fact, all the galaxies through all of time back to the Big Bang over most of the visible universe. So we've gone from this to the whole visible universe in my professional lifetime. And that's been an explosion of knowledge that has been unparalleled in all of previous human history. I know more, I've learnt more in the 30 years I've been an astronomer than was available to me to know at the time I started my PhD. That's an extraordinary statement. It really is. I have been privileged to live in the golden age of my particular field, and that's been wonderful. I'm trying to add a little more luster to the gold. I'm about to start this year a new survey of the very local bit of the universe, a very detailed survey of galaxies relatively nearby. And I'm doing
How has it been selected?
Well, it's been selected to actually, we're trying to cover the whole sphere of the celestial sphere. So I'm doing the southern half, and I'm helping a group in Spain and France do a similar survey in the north, so that we can cover the whole whole sphere,
It's
not the
just
hemisphere.
what you have access to from Australia.
Of course, yes.
Yeah, okay.
So I'm doing the south, and we're going down to a fixed limit. So we're looking at relatively bright galaxies, but all of them over the whole sky. And we're not just measuring their positions on the sky and their redshift, which is how fast they're moving away from us, which also tells us approximately their distance. But we're also measuring how they're moving, not just with the overall expansion of the universe, but they're what we call peculiar motions, which are peculiar to a particular galaxy and are in fact just the response of the galaxy falling into the nearest mass concentrations. So each galaxy has a velocity which is just the response to the gravitational field it feels from all the mass distributions around it. And by doing that, we can infer where the matter is in exquisite detail, far greater detail than if we just try and map where it all is. If we can see not only where the galaxies are, but how they're falling, then we can see not only the luminous matter, but also the dark matter, the matter that we can't see by electromagnetic radiation. And by doing that, we're hoping to measure, for example, the expansion rate of the universe to 1% precision. Now, to give you an idea, when I started out in astronomy, we didn't know what it was to a factor of 2. In other words, the error on the measurement was 100%. Over the time I've been in astronomy, we've brought that down to 1%.
Wow.
That's an extraordinary growth in such a fundamental thing, because the expansion rate of the universe tells you how big and how old the universe is. So getting that incredible precision over such a short period in human history is extraordinary. And I'm hoping to advance that just one little bit further.
The changing picture of the universe, that in itself is already something fascinating. When I was a child, I grew up in the 1940s as a child. There was a galaxy, and we called it the Milky Way.
Yes.
And that was it.
That was
our universe.
Yes, indeed.
And we knew very little about it. We knew there was a solar system, and you could dream about a moon, and which I did, of course.
Yes.
And planets like Mars, but the way that you look at it now, that in itself is a tremendous beauty, of course, when you see that picture.
That's right, yes.
Oh, it's full.
Instead of living in this tiny little tightly bound box, we've peeled away the coverings of the box, and now we can see out to the limits of the universe. Now our limits are purely those imposed by the universe itself. The speed of light is the thing that limits what we can see now, and nothing else. Our technology has changed so much that we now have a full picture of so much of the universe, whereas before we knew so little. And it's not just a bigger picture, it's much more detailed. So, for example, when you were growing up, people wondered about whether there were planets around other stars. Now we know. We know for sure that at least 10% of all stars and probably in excess of 50% of all stars have planetary systems. It may even be 90 or 100%. Furthermore, we know that all those other planetary systems, almost none are like our own solar system. They're all very different. They're incredibly varied, rich, profusely different. But there are many other planets out there which are Earth-like. We know that there are other Earth-like planets orbiting in the habitable zone around other stars. So we know that the possibility of life is out there. Maybe in the not too distant future we will even have the ability to detect it. One of the other projects I'm engaged in is a much longer term project, and that's to build giant telescopes which will have the ability to look at individual planets around other stars, and by looking at the light from their star passing through the atmosphere of that planet, to detect whether there is free oxygen there, whether there are even signs of industrial pollution there, and so detect life on those planets. That's a possibility. The telescopes that I'm helping to build today and the instruments that I'm building for those telescopes could do that in my lifetime, let alone the lifetime of my children or my grandchildren.
The more we know, the more questions.
And the more wonderful those questions are too.
Matthew, thank you very much for
It's
this
been a pleasure,
conversation. Pleasure is entirely mine.